The Leyland L60 had 6 cylinders, 2 opposing pistons per cylinder, 12 pistons total, no cylinder heads, and a cooling system that could not sustain adequate coolant flow above 25 degrees Celsius. It produced 750 horsepower in a tank that weighed 56 tons. The engine it was designed to move weighed 45. The extra 11 tons were added during development without revising the engine specification. Leyland's engineers documented every one of these problems in 1963 and submitted the documentation formally to the Ministry of Defense. The ministry approved production anyway. The British Army drove the result for 17 years. By the end of this, you'll understand why the British Army operated its primary main battle tank for 17 years with an engine its own manufacturer had formally declared unready, and why the warnings that could have prevented that were documented, ignored, and classified in roughly that order. Most people assume the L60 was a design failure, that Leyland's engineers got the engineering wrong, and the British Army paid the price for inadequate development work. That framing is wrong. The engineering objections were filed in 1963. The production decision was made in full knowledge of them. The L60 did not fail because the engineers got it wrong. It failed because the people who approved it decided the schedule mattered more than the warning. To understand how, you have to understand what the British Army was asking for in 1956 and what happened to that specification while nobody was revising it. The General Staff requirement of 1956 specified a main battle tank with a combat weight target of 45 tons. The engine was to be compact, lightweight, and capable of delivering a power-to-weight ratio of at least 16.7 horsepower per ton, the minimum the Army's offensive maneuver doctrine required. The opposed piston two-stroke architecture was selected as the theoretical solution. 2 pistons per cylinder, no cylinder head, combustion in the space between them at closest approach. The same thermodynamic principle that made the Napier Deltic exceptional applied here at a more austere manufacturing specification and a considerably tighter budget. The power density the architecture offered on paper was genuine. The margin it left for cooling and lubrication reliability under operational thermal cycling was not. That distinction would matter. Between 1956 and 1966, the Chieftain's combat weight grew from 45 tons to 56 tons. Armor protection specifications increased as Soviet tank development advanced. The gun system and its ammunition stowage added further weight. Each revision to the vehicle specification was individually justified. None triggered a corresponding revision to the engine specification. The L60 that entered production in 1966 was required to move a tank 24% heavier than the tank it had been designed to move. At 750 horsepower against 56 tons, the Chieftain entered service with a power-to-weight ratio of 13.4 horsepower per ton. The original requirement had specified 16.7. That gap is not marginal. It is the difference between a tank capable of sustaining offensive operational tempo across broken terrain and one that cannot. No revision was made to reconcile them. In 1963, Leyland's engineers submitted a formal production readiness assessment to the Ministry of Defense's Director of Fighting Vehicles. The document identified 3 unresolved problems. The cooling system could not sustain adequate coolant flow under sustained high-power operation. The lubrication system showed reliability deficiencies under the thermal cycling the 2-stroke firing cycle produced in service conditions. The production tolerances the design required exceeded what Leyland's manufacturing capacity could consistently hold at the contract volume. The assessment was specific. It was signed. It was submitted formally through the correct institutional channels to the correct authority. The Director of Fighting Vehicles approved production on the existing timeline. That decision was not made in ignorance of the assessment. The document had been received, reviewed, and formally acknowledged before the approval was issued. The Ministry of Defense was aware that the engine's manufacturer had identified 3 unresolved technical problems and had declined to certify the engine as production ready. The production schedule and the political pressure sustaining it the contraction of British defense. Procurement following the TSR-2 cancellation had made demonstrable industrial output a priority that technical readiness objections were not positioned to override. Determined the outcome. The warning existed in writing, on record, and on file. The decision was made anyway. Leyland's engineers had written down exactly what would happen. The British Army's crews discovered it was accurate. The Challenger 1 entered service with the Royal Armoured Corps in 1983. The Rolls-Royce CV-12 produced 1,200 horsepower from a conventional four-stroke diesel, a cooling system designed for sustained operation at ambient temperatures. The L60 could not sustain a lubrication architecture that did not depend on a scavenging blower's secondary function, a production tolerance specification that Rolls-Royce's manufacturing capacity could consistently hold at the required volume. Every engineering decision in the CV-12 addressed a specific failure mode that Leyland's 1963 assessment had documented. The solutions existed. They had required a different engine and 17 years to implement. The Chieftain fleet was withdrawn through the mid-1980s. The RMA mechanics who had sustained it retired with it. The informal knowledge base they had built across 17 years of operational service, the coolant additive concentrations, the pre-operation bleed sequences, the exhaust color signatures indicating rear bank thermal exceedance before any gauge confirmed it, was not captured before they left. The institution had never acknowledged it as knowledge. It had maintained that the L60 performed to specification and that the mechanics' improvised procedures were unofficial deviations from authorized maintenance practice. Unofficial deviations are not documented in technical publications. They are not transferred through institutional training programs. They exist in people, and they disperse when the people disperse. The process produced no visible event. No archive was destroyed. No decision was made to suppress the field knowledge. The Chieftain was withdrawn, the postings that had sustained the trained population ended, and the mechanics retired or transferred to CV-12 maintenance, where their L60 knowledge had no application. The knowledge dispersed at the rate the fleet withdrew. The institution that might have captured it had spent 17 years maintaining that the knowledge was unnecessary. The L60 sits within a broader pattern in British defense procurement. The TSR-2 was cancelled under political pressure before its development could establish whether the aircraft was viable. The CVA-01 carrier was cancelled on Treasury projections that subsequent analysis found to be flawed. Each cancellation was individually defensible. Each reflected the same structural condition, procurement decisions driven by political and financial pressure that operated independently of technical readiness assessments, with costs transferred to the people operating the equipment rather than those making the decisions. The L60's cost was specific. It was paid by Chieftain crews in BAOR running shutdown sequences they had memorized because the engine could not sustain the pace the tactical situation required. It was paid by Iranian tankers in Gulf heat with an engine the British government knew could not sustain it. It was paid by REME mechanics developing field procedures the institution declined to acknowledge. A Chieftain sits on static display at the Tank Museum in Bovington. The engine bay is accessible. The L60's opposed piston configuration is visible. 2 pistons per cylinder, no cylinder head, the cooling blower assembly present alongside the engine it could not adequately serve above 25 degrees. The machine the British Army operated for 17 years is available for inspection by anyone prepared to look at what the specification writers did not revise and what the Director of Fighting Vehicles approved against the recommendation of the people who had built it. The L60 did not fail the British Army through engineering inadequacy. It failed because the institution responsible for the Army's equipment chose a procurement timeline over a manufacturer's formal warning and operated the consequence for 17 years. When procurement timelines override technical objections, the cost is not paid at the point of the decision. It is paid by the crews in the conditions the specification writer never modeled, by the mechanics, developing procedures the institution never acknowledges, and by the moment the replacement finally arrives and the gap between the warning and the resolution has to be measured in operational years rather than months. Subscribe if this is your kind of story.